Alrighty, so today I'm going to talk about a new math concept I came up with called P and the power of P and what you can actually do with it, which is really cool. So P is defined as the positive unit, and there are two rules that go along with P. It is P to the K, such where K is greater than 0, equals 0, except 1, where P to the 1 is just P. Now, the other rule, P to the P, P over P equals 1. And with these rules, we can actually do something kind of cool. So I'm sure you've taken calculus before, and if you have, you know limits. And limits are used to evaluate the derivative. Well, actually, what P can do is it can also evaluate the derivative in sort of a numerical sense. And what I mean is with using those two rules that we just established, you can basically find derivatives. So here, we'll take a very famous derivative, the derivative of e to the x. This is what it would be using P. Notice here, there's no limits. So how would we evaluate this? Well, let's break this up. This is e to the x, e to the p, minus e to the x over p. Now, we seem stuck, but what can we do? Well, what's e to the p? Well, if we know the Maclaurin series of e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot, 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 dot. What happens when we plug in p? Well, we'll get 1 plus p squared over 2 factorial plus p cubed over 3 factorial. And wait, all these terms are 0. It's just 1 plus p. And this is the power of it because of our rule that we established before. Now, we have e to the x times 1 plus p minus e to the x over p. We can factor out an e to the x, and we'll get 1 plus p minus 1 over p. These cancel. E to the x p over p, and we get e to the x. So we just numerically derived the derivative without limits. And this is the power of P. And I'm going to be doing some more examples. So comments, questions, concerns. If so, leave them down there, I'll answer. If not, have a good day. On to the next one.